Hello, I'm Stefan Graeber. I'm the project leader for LXD, and today I'd like to look into Ceph. So in the previous video, I went over Oven and how we can do effectively software-defined network and have a LXD cluster with a highly available, very flexible networking layer, which can spans the entire cluster and can very easily scale and doesn't need any kind of specialized hardware or anything. Now, the other side of this is, well, if you've got your network be that flexible, you might want your storage to work the same, so that you can effectively start moving your instances whichever way you want across your cluster and not need to care where the data is stored, or like integrating nicely with the networking layer where you also don't have to care about what machine it's on. That combined with LXD clusters, highly available database means that so long as you've got 3 or more systems, you can completely lose one system and not lose network connectivity, LXD API, or any data. The only thing that will happen should you lose a system is that whatever instance is running on that system will go offline. You'll then be able to use the API through the LXC command line tool, for example, to relocate those instances elsewhere in your cluster and start them back up. You won't have lost any data and the downtime will be quite minimal. So to achieve that on the storage front, LXD supports Ceph. Ceph is probably the go-to in distributed storage solutions these days. And it's quite flexible, it's pretty powerful, and can be made to be pretty fast. In this video, I'm going to be going over how to set up a small kind of minimum size Ceph cluster using some virtual machines on LXD and just showing how that works. Again, this is going to be minimum size. If you're going larger scale, you're going to want different numbers of the different Ceph services deployed on different systems. So let's get that done and switch over to a terminal here. And as you can see, I've got 3 virtual machines running, Ceph01, 02, 03. They all have pretty similar specifications. So if I go look at their LXD config here, that's gonna look like this. So we can see they have each 2 vCPUs, 8 gigs of RAM, and on top of their normal instance drive, they also have 2 storage volumes attached, which we can list. And yeah, they each have 2 custom storage volumes. I believe I made them 50 gigs each. Let me just check that real quick. Oops, forgot the pool name here, default. Yeah, 50 gigs each. So each VM has 2 extra disks attached to them, each 50 gigs. And that's what will be used to actually store the Ceph data. Now, what we need to do first is actually install Ceph. So each of those instances is just Ubuntu 2004 and has been configured so that I can SSH. The Ceph tooling expects host names to work, so what I've done is that I've just put entries in my etc hosts file for all 3 of them. With that in place, I can just do root add ceph01 and I get as root inside of that LXD VM. Now, there are many ways to deploy Ceph. I believe Upstream currently recommends like a container-based approach using some Docker containers or using a Kubernetes cluster. That's slightly too difficult, well, too complicated, I think, for this demo. So I'm going to be using the slightly older tool called CEPH-DEPLOY, which is effectively a Python tool that uses SSH to just install the right packages and set things up. But they're also Ansible, the Ceph Ansible that lets you deploy it if you're using Ansible. There's, I believe, support for Puppet, for Juju, for a whole bunch of other things. So it's kind of, if you have a configuration management or deployment tool of choice, then just look for whatever the Ceph recipe is for that tool, because it's almost guaranteed to exist and to work well. All right, so for Ceph-DEPLOY, need to, just me clean the terminal first. it's a Python tool, so I'm just going to create a new Python virtual environment to just keep things clean. So I'm going to go inside that Ceph directory now and activate the virtual environment, and then download CEPH-DEPLOY. So I'm getting the latest version from Git. Okay, that's installed. And now we can get going. So there's going to be quite a few steps. The first one is using CEPH-DEPLOY new to just define that we've got 3 machines and we want a new cluster. It will just SSH to make sure that everything works. That should just take a few seconds. There we go. And with that done, then the next step is to install the Ceph packages. And that's going to be that command here. This will install on CEPH-01, CEPH-02, CEPH-03, the Ceph release Pacific, which is the current release. And we want some specific Ceph components. So I can just go through which ones of those are. Mon is the Ceph monitor. That's effectively the component that keeps track of where all of the data is within the Ceph cluster. The manager is like a background task manager to an extent. So it lets it can handle things like background deletion of some specific data. It can also do metric gathering and exporting. It does like a lot of that kind of admin tasks in the background. MDS is the Ceph metadata server, and that's used if you want to offer file system type features. In this case, we're going to be deploying cephfs, which allows for file system volumes on top of Ceph. So we're going to be needing that component for that. And the last one is OSD, which are effectively the disk daemons for Ceph. So every single disk that stores data for Ceph needs to run an OSD. In this case, we just have 3 VMs. I'm going to be running all of those on each of the VMs. If you had more than 3, you would normally, it depends on scale, but effectively I usually go with 3 monitors, and I usually collocate managers and MDS on those, and then put OSDs everywhere I've got drives. But on larger clusters, it might actually make sense to also locate the managers and the MDS on different machines than the monitors to kind of spread the load. And it's also possible to go with more servers and run, for example, like 5 monitors if you want. But they're using a distributing consensus algorithm very similar to what LXD itself uses. And for those kind of algorithms to work well, you usually expect an uneven number of machines in that particular cluster. So for Ceph monitors, I would go with 3, but you could go with 5, 7, or whatever else. Okay, so let's run that. This is gonna go system by system, install all of the packages that are needed. So it installs actually the Ceph upstream package repo and installs those. You could, I don't remember what the argument is, but there's a command line argument to just install the packages from the distro, because Ubuntu 20.04 does include Ceph. It includes Ceph Octopus, I believe, which is release 12. This is installing Ceph Pacific, which is release, Ubuntu 20.04 ships with Octopus, which is Ceph release 15, and I'm installing Ceph Pacific, which is Ceph release 16. There we go. Ceph release 12 is whatever we had in 18.04, I believe. So Ceph-01 is done with installing packages. I'm now doing Ceph-02. And it's really just installing all of the packages we need. There's no configuration or anything happening at this stage. Then there's going to be a few more commands to actually bootstrap all of the different Ceph services and set all of that stuff up. So almost done with Ceph-02, and then we'll get Ceph-03. In this case, I'm using some virtual machines because it was easier than finding 3 systems in my lab that were available and had external drives attached to them. Normally, I would have done this like on a Raspberry Pi, but my Raspberry Pis only have 1 SSD, which I use for the system, and don't have additional storage that I can actually put in a Ceph cluster. So I just ended up using some VMs on my system for this. It also shows just how easy it is to actually try this stuff. Like, you don't actually need spare hardware or anything. You can just do it using a few virtual machines. And it looks like Ceph-03 is just about done. The ironic thing is that the most time that this demo will take is just going to be installing packages. The actual configuration side of things goes quite a bit faster. All right, so now we need to set up the Ceph monitors. That's the first step. So again, installing Ceph monitor, well, setting up Ceph monitors on all 3 of them. It normally sets up the config, starts them, and just waits to make sure that they're kind of talking to each other. Once that's done, we should grab the keyrings that were generated as part of that. So it's a gatherkeys command that does that. This one actually failed because even though they did, the Ceph monitor started, they did not have quorum yet. Let's just that again. Okay, now it's all good. So if that one doesn't succeed, just wait a few seconds and try again. Next step is to install the Ceph. So the Ceph admin command will push the Ceph keyring and config to all 3 of the systems to make sure they're all nice and consistent. So that's good. That will let us run the actual Ceph command line tool next. Without that, you don't have the credentials to access the cluster. Next step is to set up the Ceph manager processes. So this just takes just a few seconds. And we'll follow that by installing the Ceph MDS as well on the same systems. Okay. And at this point, we've got a Ceph cluster. It just has no storage whatsoever, which makes it rather useless. So now I'm gonna be setting things up by adding OSDs. So this one is for dev SDB on Ceph-01. And I won't bore you with doing them one by one for all of the others. I'm gonna copy paste an entire bunch of them afterwards, which will add all of them. So this entire set. So that adds the second disk on Ceph-01 and then both disks on 02 and on 03. So while that's going on, I'm just gonna put that at the top here. And let's get the shell in there and we can kind of see what happens live. So if I go in Ceph-01, you can run Ceph status. And that shows you the state of the cluster. So you can see we've got 3 monitors. There's quorum, all good. The manager, the active one is Ceph-01. We've got 2 standbys running. And at the time I ran the command, we had 3 OSDs, 2 of which were functional. If we refresh that, we should see a few more now. So yeah, 5 with 4 up. And you can actually look at where they are by running Ceph OSD tree. And that shows all 3 systems and the different OSDs on them and the status. So we're currently doing the last one. And up. So if we look at status now, 6 OSDs, 6 up, all good. The total cluster size right now is 300 gigs. So that's it. I mean, Ceph at this point is effectively up and running. We could create block devices on that. We could use those with LXD. But there are a few more things to do. So because I'd like to have both block storage, which is usually used for the instance file system, whether they're containers or VMs. And I also want file systems which are gonna be, well, file systems effectively. So it's kind of akin to like a network file system like NFS or CEPH-DEPLOY, which can then be attached to multiple instances at the same time across multiple cluster members. So to do that, we need to create 2 block pools effectively, so 2 OSD pools on Ceph. One that's to store the data itself. And the 8 at the end is just a number of placement groups. In practice, Ceph just resizes things as needed these days. It doesn't really matter. The second one is for its metadata. The fact that they're separate is kind of convenient. If you have a cluster that's a mix of hard disk and SSDs, you can do things like having your file systems have their data on hard disk, but the metadata on SSD. That's what I've been doing with my own production deployments. Then create the file system itself. I'm not sure why it's called that. That's like a name that we used in our CI, I think. So let's go create a new file system, call it cephfs, and fine, we'll just call it persist cephfs so that it lines up with the 2 pools I created already. All right, so let's create a new file system, call it persist cephfs, consuming the metadata and the data pool that were created. And the last thing to do is, if you want to be able to use snapshots on top of those file systems with LXD, you need to turn that feature on, which is just allow snap creation effectively. So 1 command, and it's all done. You can look at the status. So I believe what's going on here is like now we can see that the MDS is online and running. So there's 1 daemon that's running as the leader for that with 2 standbys. That's good. And we're doing a bit of data reshuffling right now as part of, I believe what happened is that those 8 placement groups I asked for, Ceph found that it's not the right size and it's just resizing that to whatever size it feels like is more correct. So Ceph status is pretty good at showing you what's going on. So you can see that it's currently moving some stuff around. But anyway, it will fix itself. We can see that too many PGs, placement groups, so it's going to do some rebalancing for us. Anyway, the next step is to set it up with LXD. So let's install LXD. And I'll do the same on the other two. So those other machines didn't have LXD installed at all, so I'm not like upgrading it or anything, and it actually installed it from scratch, which is what's going on now. And once it's up and running, I'm gonna be doing init on the initial one. Okay, set up a cluster, IP address is fine. When creating a new cluster, no need for password. Okay, local storage, sure, we can have some of that. There's no harm in having both local and remote storage. So just use the defaults. And then do you want to configure a new remote storage pool? So yes, that's gonna be using Ceph. So that's fine. Create a new Ceph pool, sure. Name of the existing cluster. So Ceph is the default and that's correct. Name of the OSD storage pool, we can keep LXD, that's cool. And placement groups, as I said, doesn't matter too much these days. Ceph will change that. So that's all good. And not negotiating with MAS, not doing anything fancy with the network this time around. So just continuing. This should result in both a local and remote storage pool. So if we look at storage list, we have both local on ZFS and remote on Ceph. ZFS will be used by default in this case for instances. Okay, so that's good. Now need to join the other two. So I'm just going to be doing cluster add for Ceph02 and 03. Oops. I'm going to be zooming those in because I'm just going to be copy pasting this stuff straight in. And that's about all they'll be doing. Okay, address is fine. Joining existing cluster, token, yes. And it asks me for the source for local. So there's no need to set anything there. And we're done. And then 03, clustering on. This is fine. Joining existing cluster, same. Oops. And so the wrong thing here. Joining cluster. I forgot that I'm not seeing the line break at the end. I'm just getting tripped on that. Okay, this time I'm doing it right. So also didn't really need to show the YAML, but anyway. Okay, so I can close those two and just focus on Ceph01. Now, if we look at it, it's a cluster that's functional with 3 cluster members on it. So let's start. First, go with the most basic container. If I do that, because it's configured to do local by default, the actual instance is going to land on ZFS. So if we do this, and then I show U1 expanded, gonna see that the root device here is on the local storage pool. To deploy something on Ceph instead, I'm just gonna be doing storage remote. And it's unpacking it again, because this time it's unpacking it into Ceph instead of inside ZFS. And starting it. Now, you might remember, well, actually I can show it. If I do U3 now, the creation time is going to be reasonably slow because LXD needs to transfer that image from Ceph01 to Ceph03, unpack it into ZFS there, and then start it. So it took about 8 seconds. But now if I do U4 and I do storage ceph, because the storage is fully shared, there's no actual need for like downloads and transfers and stuff. Storage remote. So it can just clone it directly inside ceph and start it. So it's a bit faster. It didn't need to actually do any unpacking, so CPU-wise it's a lot faster. It took a bit longer because it's on ceph, and ceph is always just a tiny bit slower. So that's pretty much it. The other thing that's interesting with this is if I was to stop U1 and move U1 to say ceph03, let's see how long that takes. So in this case, it needs to actually do ZFS send and receive. Yeah, the problem is that my machine is very, very fast and I've got very fast networking. So it actually went really quickly. Yeah, if that instance was a lot larger, that would have been more interesting. Let's see what we get for ceph. It should be faster, but we probably won't see it too much. So I'm moving it from ceph02 to ceph03 in this case. Yeah, so it is significantly faster because no bit actually needs to be moved. The only thing that happens in LXD is a bunch of checks to make sure that everything's correct and then update the database. Whereas in the first case, all the actual storage, like those 300 megs or whatever of the container actually had to be transferred. The problem is that the machine I'm running on is really, really fast and it still just took 2 seconds. But when you're dealing with slower systems or larger instances, the difference can be from like 10 minutes to less than a second, because in one case you need to move bits, in the other one you don't. Okay. So just set them all back online. And the last thing I want to show is cephfs, which LXD init doesn't let us set up multiple storage pools, remote storage pools at once, so just need to do it afterwards. So let's create a new storage pool called remote.fs, call it cephfs, and the source is going to be that persist cephfs, and let's create a LXD share within it. And because we're in a cluster, we need to do it per cluster member, so ceph01, ceph02, ceph03, and then complete the creation by running it without the source component and without the target. All right. Now, what that lets us do, which is quite interesting, is we can now storage volume create remote.fs foo. So that creates a new volume called foo on cephfs, and now I can do. Actually, let me do this through a profile. That's easier. So I'm going to add a new device to my default profile. We'll call it foo. It's a disk. It comes from the pool called remote.fs. The volume itself is called foo, and we'd like it to be mounted as /foo in all of the instances. Okay, so that's done. And now, if I go in U1 and I touch bar in foo, so U1 is currently running on ceph03. Okay, so let's go look at U4, which is running on ceph01, and we get the exact same thing. So that effectively, yeah, that's a distributed file system that all machines can access concurrently, read and write from all of your instances. That can be very, very powerful. It's not the fastest because like Ceph does distributed storage, does replication, does all of that stuff. It's not super fast, but it's a great way to have storage that span your entire cluster and can be accessed at the exact same time. That's different from like the block devices that are backing those instances themselves. Block devices cannot be accessed concurrently from 2 different systems. That causes data corruption unless you're using a clustered file system. But cephfs avoids all of that by being effectively a network file system that you can use directly on top of Ceph. And so what we see here, that instance root device is coming from dev RBD, which is a Rados block device, and that's a Ceph block device that you're getting out of the Ceph cluster. Whereas /foo is coming from cephfs, and we can see that that's all 3 systems that it needs to talk to get the maps and everything, and then it's mounted on /foo. So that's it for a quick view of Ceph. It's a very, very powerful tool. only scratched the surface here with what's possible. Where it gets extremely interesting, I think, is when you're deploying a reasonably sizable LXD cluster, say, anywhere from like 3 to 10 or more machines, and you also have those same systems run a Ceph cluster and run an oven deployment, because then you've got complete flexibility for your storage, for your network, for all of that stuff. Like, the nice thing with Ceph is that you don't need to think about, oh, I need to put 2 of the same drives in the system to then do RAID on top of it. What you pretty much do is for every single drive you have, you run a Ceph OSD on it, everything shows up in Ceph, and then you can do quite a bit of clever tweaking there to set different type of class on each of the different disks, and based on what class they're in, they go into different placement rules, so the crush maps in Ceph. And you can then apply those rules to specific pools, and you can restrict who can access to specific pools. It's very, very, very flexible, and lets you really get as much performance out of your storage as you can, while also offering pretty strong data integrity by having by default 3-way replication. It's not necessarily the most efficient as far as disk space, especially if you're using the default of 3-way replication. Like, every byte you write will use 3 bytes, so that's not ideal. But there are other ways. There are erasure coding. There are erasure coding feature in Ceph, for example, which then gets you disk space usage closer to a RAID 5-ish type equivalent. So there's many options and many trade-offs to consider, but it's a nice thing to play with. And then when you're looking at a larger deployment, then you need to really look at what kind of classes of storage you have, what kind of features you want, and how to really build your Ceph cluster for the maximum performance. And then LXD will just consume it, no problem whatsoever. At the end of the day, all that LXD cares about is being told what OSD pool to use for its block devices, so for the instances drives usually, and what cephfs file system to consume for the file system feature, effectively. And yeah, that's it. I hope that was useful. I might end up trying to do like a bit of a video that combines both of the previous oven video with the Ceph video to show, what does a full cluster look like. I've kind of showed that in some past videos where I just had it already ready, and then I was showing things like cluster evacuation, live migration, those kind of features, which all work really, really well when you've got all of those bits put together. But it might be time to just reset up something based on what I showed in this video and the oven video, and just show what you can build easily in just a few virtual machines and play with all of that together. All right, well, I hope that was useful to you. If you've got any questions, you can leave them down in the comment section below, or you can go on our community forum. We're always very happy to answer any questions you might have. Thanks, see you in the next one.